Okay, like I said, this is very similar to what we did last class, but it is just graphing graphing inequalities instead of equations. So we've got our type of lines. This kind of made, my PDF kind of made this look funny. So your note sheet looks a little prettier than this, okay? But we have our type of lines. So what I want you to write in this table. So underneath of the equal sign, so whenever we graphed a line, what kind of line was it? Wasn't it just a solid line? It's a straight line. That's what we've dealt with so far. Okay, so underneath the equal sign, I want you to write in that column just the word solid to know that that is a solid line that we graphed. Okay, now we're going to get into these inequality symbols. Anytime that we have a less than or a greater than sign, not equal to, but just less than or greater than, what did we know about on a number line? What kind of circle did those have? It had an open circle, right? So these also go together when we graph them on regular graphs, okay? But instead of having an open circle, they're going to have a dashed line. So underneath both of those columns, write the word dashed. So just like they'd have an open circle, they're going to have a dashed line. And we'll talk about that here in a second. And then we have our less than and greater than equal to signs. And these are going to work a lot like equations. They're going to be solid lines as well. Just like if we graph them on a number line, what kind of dot did they have? They had a solid dot. So think solid dot means solid line, okay? And then these dash lines, open dot means kind of like an open line, because like a dash has those gaps in it, right? Okay. So let's keep going. Oh, hold on. Okay, there we go. So we are going to graph linear inequalities, okay? Which basically means we're going to graph them exactly as we do in equations, but we have either a dotted or a shaded line, okay? And then we're also going to have some shading with these, okay? So what I want you to write on this, it means we graph the line normal. Make sure we know if it's dashed or if it's solid, okay? So you'll make that decision. And then we've got some shading. So those are the differences here between graphing an equation versus graphing an inequality. And now we're going to look at how we've graphed inequalities so far is just by using a number line. So like for instance, again, I don't know why my PDF looks like that. Your notes should look like this. How would I solve that x minus 1 is less than 10? What would I do there? Yeah, I'd just add 1. And what would it become? X is less than 11. Okay. And then to graph it, what would I do? And I just put it on the number line, right? What kind of dot would it have? Open. And did the arrow go to the left or to the right? Left, because it's less than. You all right? Okay. So now, the difference here is that those were just plain old inequalities, right? Now we have what are called linear inequalities. And we are going to graph those on a coordinate plane. Or just a graph, right? One of those 4-quadrant graphs. Just like we dealt with last class period. Now we've got our steps to how to graph these linear inequalities, okay? So the first thing we want to do is just get it in y equals mx plus b. However, instead of it being equals, it's going to have an inequality symbol. So get in y equals mx plus b, but with either greater than, less than, greater than or equal to, less than or equal to, instead of that equal sign. Okay? And that's called slope-intercept form. Okay, so make sure you know that that is slope-intercept form. If you hear that, it's just y equals mx plus b. Okay, the next step is just to plot b on the y-axis, right? That's what we did whenever we graphed regular equations too. So plot b and then decide. I'm going to put these two little, or that little colon right there. So here is what you're deciding. Is it a less than or greater than sign? So meaning, is it a, what kind of line? What do we write down? Dash, right? If it's just less than or greater than. So you're going to decide, is it going to be dash, which looks like this? Or is it going to be less than or equal to, greater than or equal to, which is solid? Okay? So once you got that, you need to just find another point, at least another point, and draw your line. So find another point and draw your line. You just use the slope to do that, right? Rise over run. That's how I get my next point. And then we'll shade, and we'll talk about what the shading means here in a second. You can then check your answer by just plugging in a number for x, kind of like what we did with those extraneous solutions. You don't necessarily have to do that on all of these, but I'll show you what it means here in a second. All right, so let's go ahead and start with example 1. So we need to get this into slope-intercept form. What happened to my graph here? Whoa. Okay, there we go. So we need to get this into slope-intercept form, which means we need y on one side, x on the other, right? So how am I going to solve this one? How would I get y by itself? What should I move first? Yep, so subtract the 4x over. So this just becomes negative 3y is greater than or equal to 6 minus 4x, or just negative 4x plus 6. Either way, it means the same thing. Okay. Now what? Divide by negative 3. So everything gets divided by negative 3. When I divide on the right side by negative 3, so I can write it like that, okay? But know that that is the same thing as negative 4x divided by negative 3 plus 6 divided by negative 3. Are we all good on that? So that's how I split that, okay? So I'm okay to write it either way. It means the same thing. So negative 3 divided by negative 3 on that left side just cancels to give me y. But one thing I forgot to do here, when I divide by a negative, what happens to that inequality sign? Yep, it's got to flip. So we got to make sure we still do that in this section. So we end up with y is less than or equal to negative 4x over 3, over negative 3. What do those negatives do? They cancel, so this is just going to be 4/3 x. And then plus 6 divided by negative 3. Negative 2. Good. So you can see how like that kind of looks like y equals mx plus b, right? It just has an inequality sign. So we're going to graph it very similar to the y equals mx plus b. We're still going to plot b, which is at negative 2. So I'm still going to have a point on my y-axis at negative 2. The 4/3 is still going to be my slope. Okay, so I can go ahead and I could make another point right now if I want to. But now I got to know, what kind of line is this going to be? So let's look. If it's less than or equal to, what kind of line is this going to be? Solid. Okay, so it's going to work just like an equation. So I could just go with that one point I can make a few more if I want my line to just look a little prettier, but it's going to end up being a line that looks like this. So far what I've done, I haven't really done much different yet, right? Here is what is different about an inequality graph versus a regular one. So this is y is less than or equal to or greater than or equal to? Less than or equal to, right? So looking at my y-axis, that's which axis? The one going left to right or up and down? Up and down, right? It's this one. So looking at that axis, what direction would be less than my line? Like going down or going up? Down, right? So I'm getting less than if I'm going down. So what I'm going to do is I'm going to shade all of my values that are less than my line, which actually means that the whole right half here is the section that I'm shading. Do we see how that's less than the line? Because it's like going down the line. So you just look at the y-axis and that tells you which part to shade. If it would have been greater than though, we would have shaded up. And we'll talk about that here in a sec. Okay. Wow, what we got going on here. Okay, example 2. We've got y is less than 2x plus 3. So this one's actually easier, right? Because it's already in y equals mx plus b, but with an inequality sign. Do we agree? Yep. Okay. What would be my first thing I'd do on this one? So I've got it in the right form. What am I plotting first? The 3, and it's going to be on my y-axis, right? That's where b values go. So b was 3 on this. What's m, or my slope? What is the slope on this one? 2 over 1. So I'm going to make another point. So I'm going to go up 2 over 1. I can make as many points as I want to. All right, let's make a decision now. What kind of line is this going to be? Dash. Okay, so how I'm going to do that is I'm just going to pretend I was drawing a straight line, but it's just going to have these dashes instead. You could like draw a solid line and then like erase little chunks out of it if that helps you, or just draw a good little dashed line there. Is this less than or greater than? Less than, which means I'm shading down, okay? So is that going to be above my line or below my line? Below. So it's actually going to be all of this. Okay. So, questions on that one? Okay. X is greater than 7. Remember what these equations, if I graphed an equation that said was just x equals 7, what would that one look like? It would be a line, yeah. Do you remember the acronym? It wasn't HOI, right? Because this isn't a y equals, but what was the other one? VUX, good. That was the x equals one, right? And what did the V stand for in VUX? Vertical, right? So this was going to be a vertical line through where x is 7. So on my x-axis, that was just at 7, right? And that would just be a vertical line going up and down through that. But what kind of sign is this? It's greater than, which means what kind of line? Dash. So really this needs to look like a dash line. Whoa. Okay. And if it's greater than 7, do you think I'm going to be shading left or right? Right, okay, because it's all the values on my x that are greater than 7. So we're shading to the right on that one. Any questions on that? So do you think like a hoi, so like if I had like y is less than 3, wouldn't that work similar? Maybe? Yeah? Okay. The second number 3, we're not ready for number 4 yet. We have 2 number 3s. Okay, so let's look here. How would I get y by itself on this one? Subtract x, good. Okay, so negative 2y is less than negative x plus 5. Or 5 minus x, whichever one. I just like to write x first, because then y equals mx plus b. The x is written first. Okay, what comes next? Yeah, we gotta divide by that negative 2. So everything gets divided by negative 2. When I divide by a negative, my sign does what? Flips. Negative 1 over negative 2. What happens there? Yep, it becomes positive, so this would just be x over 2 or 1/2 x. You could also leave it as a decimal, 0.5. And then 5 divided by negative 2. Do we want to use a decimal or just a fraction? Fraction. So just leave it as negative 5/2, which would be 2.5, right? Negative 2.5. Okay. So to plot that, negative 2.5 would be between what 2 numbers on the y-axis? Negative 2 and negative 3. Good. My slope is, yep, it's 1 over 2, so I'm going to rise up 1, go right 2. I can make as many points on here as I want to. Really doesn't matter on that. What kind of line? Dashed. And where's the shading going to be on this one? Above. Why is it above? Because it's greater than, so we're going above. The shading is fun, right? You look like you were having fun with that back there. No? So number 4 was my one that disappeared. This was y is less than 3 or greater than 3? Greater than 3? Okay. Was this a, what kind of line would this be if it was just y equals 3? Horizontal, right? This would be one of those hoys, like the cookie, Chips Ahoy, right? Because we know that if it starts with a y equals a number, it's going to be horizontal. Okay, so going to where y equals 3, so on my y-axis, I know I'm having a horizontal line through that point. Dashed or solid? Dashed. Shade above or below? Above, because it's greater than. Good deal. All right, go ahead and do 5 and 6 on your own. We'll go over them quickly. We'll do number 7 together, and we'll be done with notes for today. How's that sound? Not bad? I don't think it sounds too bad either. So get going on those. So number 5. There it is. And it doesn't have a very good graph, so we'll put a new one in there. Alright. Y is less than or equal to 3x. Okay. How do we start this one off? What did we do? Did it have a b value? No, so what does that mean that the b value is? 0. So we'll put a point in the middle. What about the slope? So b is 0. Slope is 3, which is the same as 3 over 1. Good. So to make some more points on this, we'll go up 3 over 1, up 3 over 1. Make as many or as little as you want. As long as you've got 2 points, you're good to draw a line. Dash or solid? Solid. Shade above or below? Below, because it's less than. So that means I'm shading towards the bottom of that y-axis, which ends up being below this line. Do we all see how that's below the line? Okay. Cool. Let's go ahead and we'll do number 6 up here. Just because I've got to throw in a graph. Number 6 is y, what do we got? Oh. Number 6 is 3x is less than 9. Okay? Can we solve this one as it is? Yeah, we can. But we gotta do one thing first. Divide by 3, right? It's a positive 3, so I don't have to flip the sign. This just becomes x is less than 3. Is that a hoy or a vux? If it ends in an x, or starts with an x? A vux, right? Which means it's going to be a, what kind of line? Vertical through the number. Yep, where x is 3. Dashed or solid? Dashed. Shade to the right or to the left? To the left, to the left. Because it's less than. Are we good on that? Yep. Feeling solid? Okay. Last one we got today. Move that up. Okay, last one we have today is this absolute value one. There won't be one like this on the test, but I still want you just to have it in your notes because it's going to help us for whenever we get into further sections in this semester. So to split an absolute value, we are going to keep the first one the same. The next one, we're going to flip the sign, and we're going to make the right side negative and drop those bars. But instead of bars, I'm going to put parentheses just because I'm making that whole thing negative. Okay? With me so far? So now I'm going to graph the first one, y equals 2x plus 3, or y is greater than 2x plus 3. What's the b value? 3. Slope? 2 over 1, right? And that's going to be a dashed or a solid line? Dashed. So it's going to look like this. All right, the next one, I'm going to distribute out this negative just so I have my equation the right way. So negative times 2x, and then negative times 3. It just gives me y is less than negative 2x minus 3. Now I'm going to graph that. So the b value for that one is negative 3. Good, thank you. And the slope? Yep, negative 2 over 1, so I'm dropping down 2, going right 1. I can make some points up here too. Dash or solid line? Dash. So basically these absolute values are just graphing 2 lines on the same. We do have shading on these. This is where it gets a little bit confusing. And we'll save that for a different day. We'll just leave it like this for now. This won't be, I don't think this is on the homework. Let me check one time. Yeah, so you don't have to do the absolute values on the homework. We're going to save that for a different day.
So we just cross it off?
Yep, cross off 11 and 12. You don't need to do them. All right, that is all I got for today. Any questions on anything? Cool.